So I'm saying let's maintain our wonder because we might discover something we've never expected.
The 9th annual Contact in the Desert Conference happens the weekend of June 2nd at the beautiful Renaissance Resort near Palm Springs, California. Join me, George Noory, to discover what's next from speakers such as Graham Hancock, Loeb, Caroline Cory, Richard Dolan, Stephen Bassett, and over 50 other top researchers. Come make contact with new friends and discover the latest fascinating information from the fields of UFO studies, artificial intelligence, psychic phenomenon, and more. Reserve your seat now at contactinthedesert.com.
Welcome to New Realities. I'm Alan Steinfeld, and this program is about the expansion of human awareness. And that is why I'm so happy to have with me today Abraham Loeb, who was the head of the Harvard Astronomy Department, but his most important contribution to humanity is that he noticed or speculated that perhaps the thing that passed through our solar system on October 17, 2017, was perhaps an extraterrestrial vehicle, perhaps. And the speculation went out, and I acknowledge you for doing that, to the astronomy world, and they had a severe reaction. Why did they have such a severe reaction to that speculation?
Because it didn't represent past knowledge. And one of my colleagues, after we heard a colloquium, a lecture about this object, Oumuamua, that was discovered by a telescope in Hawaii. My colleague who worked on solar system rocks for decades said, Oumuamua, this object, is so weird, I wish it never existed.
The big question I do want to ask you, what percentage do you think does life exist in the universe besides? Yeah.
So I think it's arrogant to think otherwise because we now know several facts. We know that most of the stars formed a few billion years before the sun. And that means that their clocks started ticking a few billion years before our clock. So, and there are billions or tens of billions of other stars in the Milky Way galaxy alone. And, a trillion galaxies like it in the observable volume of the universe. So now you ask yourself, okay, suppose we just focus on the Milky Way galaxy, which is one out of a trillion other galaxies. And we ask, if you roll the dice tens of billions of times, what's the chance you will end up with something like us? We know that somewhere between a few percent and 100%, so a significant fraction of all the stars like the sun have a planet the size of the Earth, roughly the same separation. We know that from data that was collected over the past decade. So especially with the Kepler satellite. And so that tells you that conditions are not unique or special. We are not privileged in what we find around us in the solar system. And as a result, I tend to assume that the outcome is not special, that things like us existed and they must have existed, billions of years ago. And it takes less than about 500 million years to traverse the entire Milky Way galaxy with the kind of rockets that we produce, chemical rockets. So there is plenty of time for any civilization that predated us by more than 1 billion years to reach us with their probes. And the other thing is that these probes, chemical rockets, reach terminal speeds that are below the escape speed from the Milky Way galaxy. So they cannot escape the pull of gravity, and they should still be around. So before, in the past 70 years, we've been searching for radio signals and laser signals. And that is equivalent to waiting for a phone call. Yeah. You need the counterpart to be transmitting so that the signal will reach you at the time that you're looking for it. Whereas what I'm talking about is going out to check your mailbox for any packages that accumulated over time. And it's a completely different search method. And only over the past decade, we discovered the first objects from outside the solar system. So what I'm saying is, why should these objects look so weird? The fact that we found some objects and 3 of them, 2 meteors and Oumuamua, look unusual, they don't look like the familiar rocks from the solar system, says something, says that we need to get more data, more evidence, and it's very intriguing. And obviously, people that are used to playing with rocks, like my colleagues, they would respond to it the same way that a cave dweller will respond to a cell phone. A cave dweller would say, it's a rock of a type that I've never seen before, but it's still a rock. And if the cave dweller has a kid, the kid might go and press some buttons and realize that it's not a rock.
Well, thanks for being that kid. But also Gary Nolan's idea, because he's on your board, I'm sure you're familiar. He speculates that DNA may be 10 billion years old, which is 5 billion years older than the Earth. So, do you know that speculation?
Yeah, I know this argument. That was based on a scientific paper that other people wrote.
Yeah.
And the only question there is how accurate is the dating. So what they do is follow this. The same as Moore's law, that that there is a characteristic doubling time of information, and then going back in time and realizing when everything started. And the question is whether a factor of 2 error in the starting time in terms of what we recover versus what it was supposed to be. It was supposed to be the age of the solar system, but it's actually going back farther. Whether that's significant, or maybe the assumption of an exponential growth in information is incorrect. And that's not clear because the Earth went through periods where it froze. It's called ice ball. It became an iceberg, basically. And it's not clear whether the process itself was affected as a result of these traumatic changes in the climate of the Earth. And but if you do follow this argument, then it says maybe life was brought to Earth from somewhere else.
Right. Even in your papers on Titan, you talk about organic molecules that could potentially hold the manifestation of a DNA substance, right? You don't quite say that, but you do say organic molecules. So
right. Titan is really interesting. It's a moon. It's the only moon in the solar system that has an atmosphere. Our moon doesn't have an atmosphere. And the atmosphere in Titan is mostly nitrogen, similar to Earth. But its surface temperature is very low. It's about a third of the temperature above absolute zero that Earth has. But there are rivers, seas, oceans of methane and ethane. And these are fluids that are not flowing on the surface of Earth. But the question is whether life as we don't know it may exist in these fluids. That's possible. And underneath those, there is rock and frozen ice, basically. And under the ice, we know that there is liquid water. And the question is whether there is life as we know it under that ice and in the liquid oceans that are underneath. That's called the subsurface life. And so what I'm saying is really interesting for us to go there and figure out, is there life as we know it or don't know it? And if we do find life, it holds a promise that life started very early in the universe, because the surface temperature of Titan is 94 degrees Kelvin above absolute zero. And that was the temperature of the entire universe, 100 million years after the Big Bang. So if Titan has life, then an object like Titan that may have existed at that time, 100 million years after the Big Bang, because it's after the first stars started forming and producing heavy elements. So if you had an object like it, it didn't need to be close to a star like Titan is to the sun. It could be anywhere in the universe, and the surface temperature would be 94 degrees above absolute zero. So life could have started as early as 1% of the present age of the universe. Just 100 million years after the Big Bang, and that's remarkable. We came late to the party. It has been going for a while, probably, and we tend to think that the party is about us, that the cosmic play is about us. But the truth is, we are not at the center of the stage, and we arrived at the end of the play. So my point is, the play is not about us, and we better find other actors that can tell us what it's about.
If they know what it's about. So that's what I wanted to ask about the Galileo project. That's probably the most important thing you're engaged in. And I couldn't help notice that you have some very connected UFO people on your board. Jacques Vallée, Louis Elizondo, Nick Pope. So you're looking for stuff out there, but according to my research, these people are convinced that we have been visited. How do you deal with that when you're still looking out there and they're saying, look, it's right here?
Yeah, no, in fact, one branch of the Galileo project is to develop instrumentation that will get better data about objects in the Earth's atmosphere. And these are called unidentified aerial phenomena by the US government, the intelligence agencies. And we are planning to collect that data. In fact, we're already starting to get data and analyze it with artificial intelligence algorithms and get much better data than anyone else before. And the government holds the data close to its chest in the sense of it being classified, so we can't really access it. Now, the way I constructed the Galileo project is to invite people that are advocates, that they believe, as you mentioned, in the unidentified objects being potentially from an extraterrestrial origin. But I also have skeptics within the project, such as Seth Shostak or Michael Shermer. And the reason I bring these people with opposite opinions, both believers and skeptics, is because eventually it will be the data that will guide us, that will show us the way. And once the data is convincing, both sides will agree with each other. So that's a sort of a canary that I take to the cave that will tell me when we have good enough data, because at that point, everyone would agree that there is something conclusive out of it.
Well, I'm not sure if it's just belief, because I think someone like Elizondo, who was an intelligence officer and on the inside of the advanced aerospace space program, probably saw something that shifted. And what if he said, Avi, I have something to show you? Would that change something for?
Well, okay, so I actually had a conversation this morning with a theologian, and he was telling me about people who had experiences, they saw something, and was asking me about the context of these unidentified objects. If someone comes to me and says, I saw this, I saw that, and I try to explain that all of these reports are the interaction of people with the reality that we all share. I'm interested in the reality that we all share. Of course, if I were a psychologist, I would be interested in the human part of this interaction, okay? But I don't care about that. I want to figure out the reality that we all share, just the same way that Galileo Galilei figured out that the Earth moves around the sun, okay? And that's the reality we all share, because the Orion spacecraft looked at the Earth, looked at the sun, and saw the Earth moving around the sun. So we know it's real by now. So the point is, how do you figure out the reality we all share? Well, the reports may be intriguing enough, but the idea is to use the scientific method, which is based on instruments, collecting data, and the data should be reproducible, and you should fully understand what the instruments are doing. So that's the method we are using in the Galileo project. And if Lou Elizondo tells me, there is something interesting, go ahead and check it, then of course I'll use my instruments to tell me. But I will not rely on what he tells me, because that is not scientific evidence. And experiences that individuals had, they could guide us in what to look at, but they are not really evidence. You can't write a scientific paper saying this person told me that, because people are not scientific detectors. They are often unreliable. They could have hallucinations. You can put goggles on your head and live in the metaverse where the sun moves around the Earth. Would that be evidence? Well, obviously you had that experience, but it's not evidence that the sun really moves around the Earth.
I'm sure you know the work of John Mack at Harvard, professor of psychiatry. Right. And what did you think of when he talked to experiences? Yeah,
so that's exactly my point. He was focusing on the human component, and that's completely opposite to what my focus is. And I do not want to rely on the human component, because throughout human history, people made false claims. There are so many examples where people, Even, if there is a report about a car accident and you consult different people that witnessed it, you end up getting very different reports. And the reality that took place is a single reality. But if you had a high resolution camera, you wouldn't need to rely on these people. You would see exactly what happens. Mm-hmm. So I want to develop that high resolution camera. I don't want to rely on Lou Elizondo.
Well, do you think the Webb, which is a high resolution camera, is likely to find something? I mean, are you betting on that telescope, the Webb?
No, so the Webb telescope is viewing a small part of the sky, only about 1/10 of a degree, which is like of order 20, about 1/5 of the size of the moon. That's the small region of the sky that the Webb telescope can look at any given time. So it can't survey the sky. So what the Galileo project is doing is have instruments that survey the entire sky all the time. Okay, that's of course, if there is an object like Oumuamua that comes within the orbit of the Earth around the sun, we could use the Webb as a second eye. We have two eyes that allow us to figure out the distance of things we are looking at. So if we have the Webb from a distance of 1 million miles and Earth-based telescopes looking at the same object, you can pin down the trajectory of the object in 3 dimensions very precisely. So you can tell if there is any propulsion in addition to the force of gravity acting on the object. So that's the plan, to use the Webb when we identify an object like Oumuamua. But Webb will not be the one to identify it. There is the Vera Rubin Observatory in Chile that will start operations in a year and will survey the southern sky every 4 days, the entire sky, and it will have a camera with 3.2 billion pixels, so 1,000 times more pixels than a cell phone.
Great. Were you familiar with the? I know you're Israeli. The Israeli minister that came out, Hashed, and what do you think of that?
Right. Comment? So he did not provide evidence for what he argued, and there are lots of people who come forward and say that they are Napoleon, for example. And then the way to figure out if this is the real Napoleon or not is to ask for their ID. And obviously, if they keep insisting while the ID says something else, there is a place for those people. So the point is, in order to figure out if there is any substance in what he says, I need to see the evidence. As a scientist, I haven't seen the evidence. People can say whatever they want. Now, it's possible that he had access to the information that definitely supports what he said, but I haven't seen it.
Well, did you see Carolyn Cory's movie, Tear in the Sky? Do you know what I'm talking about?
Yes, I did.
And what about the evidence she shows of those portals and objects?
Well, it was based on 5 days of a trip to Catalina Island, and 5 days is not sufficient to collect enough information, scientific information. And also it was not clear exactly how well understood were the instruments, because they just rented them for 5 days. So we will try to do a better job with the Galileo project, in the sense that we own our instruments. We will use them for months and months, not just 5 days. And we have them fully calibrated. They are at our possession, so we know exactly what we are doing. And that is the way science should be done, not by a documentary filmmaker that is just going for a stint, like a short period of time, get some data, makes a documentary, and get some splash out of it.
Well, are you looking at, like, she went to Catalina Island because it's a hot spot for sighting. Are you?
Yeah, no, I mean, it's possible we will. It's possible we will go to a number of locations, and quite possibly this would be one of them. So, we will visit a number of locations, and we have to converge exactly which ones. But at the moment, we just started to get data from the first system that we are testing. And then we are ordering copies of it. And at the point, once we have those copies, we will go places.
Do you think the government may know more than it's telling its citizens and its scientists, for that matter?
Well, if I had to guess, I would say the government has some data that is confusing, unclear. And the government is not a scientific organization. And it's also very concerned about classification, about the adversaries being aware of the kind of sensors that the government is using to monitor the sky. So because of that, it's not a transparent organization, and it's not necessarily full of scientists that can figure it out. And it's mostly focused on national security and the safety of military personnel. So its objective is very different. If it sees something that is not clearly human-made, then it simply ignores it because it's not a matter of national security. So, or classifies it as unidentified. So my point is, instead of waiting for the government to declassify its data, which could be forever, because just like the play Waiting for Godot, you can wait forever, it will never come. We can just take action to our hands. That's what the Galileo project is doing, and get our own data, because the sky is not classified and we have our own instruments that we bought off the shelf.
But I want to ask you, is looking for life the most exciting thing possible for an astronomer like you, or are there things that are more exciting or just as exciting?
No, it's the most exciting because it holds the key to everything else. You know, I can foresee in the next century 3 revolutions. One of them is already happening, and that's the artificial intelligence revolution, where AI systems replace humans on many tasks, and, for example, prescriptions and that doctors currently provide, and all kinds of administrative jobs, and obviously driving cars. They will replace taxi drivers at some point. So AI would take place of humans, and eventually AI systems will converse with each other, and that will be a whole different part of the revolution of AI. The second revolution that may happen is that the human lifespan will be extended once we understand how to repair the human body better than we are able to do right now. And that, of course, will change everything, because society will have to respond to that. And, for example, it would make no sense to have tenure in academia if people live much longer than 100 years, you know. I mean, you want the young people to have jobs as well. And then the third revolution will come from discovering that there is a smarter kid on our cosmic block, and that's the one you refer to. And in principle, that holds the promise of telling us more about the other 2 revolutions. So, because whoever sent whatever we find may have already figured it out. If they had a head start of 1 billion years ahead of us. I would say that would be the most consequential, the most exciting one, and therefore that's what I'm focused on.
Right. And when should we expect to hear something from Galileo?
Oh, so I think within a year we'll already have some interesting results, because we're going on this expedition, and we are also collecting some data by now. And so by summer 2023, we'll have some interesting things in our bag. And then how quickly we write the papers as a result of that will depend on what we find. But definitely within the coming year, it should be exciting.
Well, when you get those reports, let's come back on the show and we'll do a longer interview.
Yeah, I'll be delighted. I also should mention I have a book coming out on August 29th, 2023. It's called The Interstellar, and I just went over the final draft yesterday. So I will be glad to discuss it once it comes out as well.
Yeah, who's publishing that book?
HarperCollins. They have it on their website. If you just Google Avi Loeb, Interstellar, HarperCollins, you'll see it.
Of course, your extraterrestrial book was a bestseller.
It was, and it was translated to 25 languages, 3 editions in Spanish, altogether 28 editions. And it became bestseller in many countries, including the New York Times bestseller list. And it attracted some 35 filmmakers and producers to contact me about doing something about it. And so altogether, I had about 2,000 interviews over the past 2 years as a result of Extraterrestrial. We shall see what the new book, Interstellar, brings about.
And Interstellar is a further development of what an intersolar object might really be like. Is that the speculation in the book, Interstellar?
Well, the book talks about what happened since my previous book appeared, and it includes the Galileo project, it includes the new objects that we discovered, and what we are hoping to find, and the implications to humanity as well. So there are many interesting elements to this new book that make it even more exciting, I would argue.
I mean, did Jacques Vallée ever give you some of the supposedly slag he got off of these down UFOs? Has he showed you that?
Well, I met him for dinner, and it was really interesting. And he gave me one of his books dedicated. And yeah, I mean, he's one of those pioneers. And what I'm trying to do through the Galileo project is substantiate all of these conjectures or claims or ideas that were proposed before. And I think it's a new frontier, and only over the past decade we had access to interstellar objects in astronomy. So we are likely to find something new. And since it's a path, a road that was not taken, there might be some low-hanging fruit.
Well, I think developing an interstellar civilization would be another aspect to that. So
right. And that I think we have to think big, because eventually we'll have to go to space. There is no doubt about it, and others may have done it already. That may be our wake-up call.
Do you think Mars had life? Or
I think it probably had, because it started with liquid water on the surface. We know that from all the evidence. There was an atmosphere to Mars, and then it lost it about 2.5 billion years ago. That's roughly the same time when the Earth started to have a lot of oxygen in its atmosphere. So it's interesting that there were bad news and good news in the solar system about life. On Mars, life was extinguished because the atmosphere went away, and all the liquid water on the surface evaporated. Without an atmosphere, it cannot remain. And at the same time, roughly about the same time, Earth started to develop oxygen in the atmosphere. It's not clear what the trigger of that was 2.5 billion years ago, that the oxygen level rose dramatically by cyanobacteria. We know what produced the oxygen, but the question is why? Why did it start rising around that time? And it was obviously essential for the development of complex forms of life later.
At first, it was a poisonous gas, oxygen, you know that, and then cells mutated to use the oxygen, and then
right. But it was essential for our appearance, and obviously.
But where does all the water come from on Earth, on Mars, on Titan? Where's the origin of water?
Well, oxygen is produced in stellar interior quite abundantly, together with carbon and nitrogen. And that's why you find, it's called the CNO cycle, that you burn up, you fuse hydrogen to helium through a process that ends up making also carbon, oxygen, and nitrogen. And so that's why you find these elements which are crucial for life. The carbon is really essential for organic chemistry, and then the oxygen for the water in which the chemistry takes place. And hydrogen was abundant from the Big Bang, so that's not really. But nitrogen is abundant in our atmosphere, in Titan, other places. So all of these elements were produced in stellar interiors. They were quite abundant, and they enabled the chemistry of life as we know it.
Do you think we'll ever be able to build a Einstein-Rosen bridge or a wormhole through space-time?
Well, we don't know if such things exist in the real universe, and we definitely don't know how to make them. So it's a complete speculation, and most likely we will never have a time machine going back in time, because that leads to a lot of problems in physics if that was possible. So I would think that there might be ways of propulsion that are much better than what we used so far. There might be ways to move close to the speed of light. And frankly, if anyone else was moving close to the speed of light, astronomers would probably not notice it, even if it went through the solar system near the Earth, because it's just moving too fast. But rather than think about time travel or wormholes, I think just moving close to the speed of light is good enough.
Well, but black holes may bypass the, speed of light by creating loops in time-space. That's
Yeah, but we don't know if these are real, because so far all the solutions based on Einstein's theory of gravity are unstable. So we need to incorporate quantum mechanics, and then we don't have a quantum mechanical theory of gravity. That's the problem.
But black holes do exist, right? They do.
Oh yeah, we have an image. I founded the Black Hole Initiative at Harvard University, and we obtained an image of the black hole in M87, so we know it. And also gravitational waves were detected from the collision of black holes, so we definitely know that black holes exist.
Gravitational waves, and maybe we can harness those waves. I know you. And is black holes, can you measure the mass of a black hole? Because if you could, maybe we're off on our measurements, and in which case there might not be any dark matter or dark energy. It may actually be contained.
Oh, no. The evidence for dark matter and dark energy comes from other directions. We can measure the expansion rate of the universe in different ways, and we see that there must be a substance in addition to the ordinary matter filling up space. And we also find evidence for it in the outskirts of galaxies, where the ordinary matter doesn't account for the full gravity, and also in clusters of galaxies. So we know that dark matter exists, but has nothing to do with black holes. And with respect to black holes, we can measure the mass. Yes, if we have an object moving near a black hole, and we see it moving, then we can infer the mass. Or from gravitational waves, we can use Einstein's theory of gravity to figure out what the mass of the black hole was. So these things are done, and black holes are very exciting. They are extreme structures of space and time. We know they exist, but we still don't understand what happens to matter that falls into a black hole close to the center.
And parallel universes, are they just fictitious science fiction, or they?
Yeah, we don't know if they exist because we don't have access to them. So some cosmologists that study the universe argue that maybe there is the multiverse, where there are many other regions of space and time where anything that can happen will happen an infinite number of times. And these are speculations. I wouldn't give them more credit than philosophical ideas, or if you want science fiction literature, because we have no evidence for those things. And it's really the evidence, the data that should guide us. Of course, the human imagination, can lead to speculations, which are good because they inspire us, but they are not proven scientific ideas. They are just speculation.
Well, that's what makes you such a solid scientist. Thanks for being so grounded. And we need people like you in order to convince the other parts of the world that something else is possible. So thank you for
I just wanted to say before we close that there are two risks to following common sense. One comes from people who are just advocating for something without any evidence for it. And, they can advocate for anything. You see this a lot in politics. People can say whatever they want without needing to provide the evidence. That's one problem that I'm trying to resolve by trying to collect data. And the other side is in academia, the scientists that are not imagining something that is unknown or unexpected or wonderful or magical or different than what we are familiar with, something that is not based on our past knowledge. And as a result, they don't explore the unknown. And I think we have both problems, and I'm trying to walk in the middle, following common sense when things that look unusual require more evidence for us to be sure what they are. And I'm saying, let's collect that evidence, while people from both sides, there is one side that says, I already know the answer. And another side says, I also know the answer, that it's nothing. We shouldn't even do that. And unfortunately, both extremes do not lead anywhere. And you need to follow common sense and collect the evidence. And eventually we'll learn something new.
In the journey of Homer, Odysseus had to sail between the whirlpool and the rocks, and you're sort of doing that,
Exactly. And it's not easy. It's not easy because both sides pull in their direction, but I'm trying to maintain my course, and so far it's going well.
Well, both sides are stuck in dogmatic philosophy, scientism. Science says they have the answer. But they couldn't explain why rocks fell from the sky in the 1800s. So
right. Right.
And so,
Yeah, there are many examples where people were just wrong when they followed these approaches. Yes, definitely. And we still don't understand some parts of physics, like entanglement in quantum mechanics, or what happens inside a black hole, or what happened before the Big Bang. So I'm saying let's maintain our wonder, because we might discover something we've never expected.
I'm on your side there. So thank you for maintaining the wonder is what changes the world. So thank you.
And thanks for having me. It was a
Marie
real pleasure.
Loeb from Harvard Astronomy Lab, and the author of the upcoming book, Interstellar. Check out his first book, bestseller, Extraterrestial. I was a little upset you popped me off my bestseller list on Amazon when your book came out. So that's okay. Anyway, thanks for your time, Avi, and your work and your dedication to wonder and the human experience and trying to understand what the real nature of existence is. We need scientists like you.
Well, that was the way I was as a kid, and I just remained that way. That's all. I refuse to become an adult that knows everything.
But you had a good education, and I'm glad you're in the position you're in to help a lot of people realize a bigger reality. I'm Alan Steinfeld. You've been watching New Realities. Thank you, Avi. I will see you at Contact in the Desert, June 2nd to the 4th.
At the beautiful Renaissance Resort and Spa near Palm Springs, California. Come discover what's next in the fields of UFO studies, governmental disclosure, artificial intelligence, psychic phenomenon, and more. Join me, George Noory, along with top international researchers, scientists, and authors to make first contact with new friends and the latest and most fascinating information. Choose from over 130 multimedia lectures and panel presentations by the likes of Graham Hancock, Avi Loeb, Caroline Cory, Richard Dolan, Stephen Bassett, and a host of over 50 leading experts and researchers. See them live in person and find out things you just didn't know. Browse interesting and unusual items in the exhibitors hall, enjoy films and special evening events, and relax at the beautiful resort and surrounding areas with activities like golf, tennis, swimming, and more. Reserve your seat now at contactinthedesert.com.